So let us get started. So good evening and welcome you all to this session on this value stream mapping. So first of all, I would like to thank all of you for joining this session. And I hope that all of you will have a wonderful learning experience. So before starting, I would like to just take a small poll or a small feedback. So you can type your answer in the chat box, yes or no. So question number 1. So do you already have prior knowledge on lean management, yes or no? So you can type the answer in the chat box. So do you have previous exposure to lean management, yes or no? Okay. Okay. So how many of you know, have some, at least you have heard about this value stream mapping? Have you heard about this value stream mapping before, yes or no? Again, can you type your answer? Have you already heard about this term, or have you know something about what is value stream mapping? Okay. So I can see that there are some people who are from our own alumni students. So they are responding yes, but maybe most of you are new to our this learning journey. Okay. So I'll just give some brief introduction about what is lean management, and what are the different types of waste, and then what is value stream mapping. And then I will just give one example of how this value stream mapping can be solved, can be used for solving a problem in your process, right? So by using the AI tool. So I will randomly pick up one person from the audience who is the participant today. And we would like to hear from him what is the problem he's having and how to solve the problem by using this tool. So again, we'll spend some time on that. Okay. Okay. So first, let us learn a few fundamental concepts about what is lean and how it is useful to you. So lean is a methodology for identifying and eliminating waste in the process. So this was popular in Japan starting from the 1950s. So all of you are aware that the Second World War was fought between 1939 and 1945, and the war ended when United States of America, they dropped atom bombs on two Japanese cities, Nagasaki and Hiroshima. And after the Second World War, Japan's economy was devastated, and they were working very hard to come out of this problem. And the United States of America government, they sent a lot of experts from different fields to help the Japanese people to come out of their problems. And they sent a lot of quality experts also. So they actually helped the Japanese people to improve the quality and productivity. And that's where the lean was slowly evolved. So the pioneers for this lean was Toyota. So Toyota, they were initially in the early 19th century, they were in the handloom business, and they started their automobile business in the year 1935. But immediately the Second World War came, and they were not very active. And after the 1950s, they became very active, and they were the pioneers for implementing lean. So lean is a methodology for identifying and eliminating waste in the process. So no need for any one of you to record this session locally. We will be sharing you the recording. So no need for anyone to record it locally. So lean is a methodology for identifying and eliminating waste. And there are 8 types of waste, which we'll be learning shortly from now. So whenever we are doing any activity in the end-to-end process, then those activities can be broadly classified into value-added activities, non-value-added, and business non-value-added. So whenever you are doing some activity, whether it is manufacturing process or the service process or healthcare process, any process, we are doing some activity. So for this activity, we can classify into these 3. So what is the meaning of value? So value means it is actually what the customer is willing to pay for. Value means change in shape or form. Change in shape or form for which the customer is willing to pay. For example, if you are producing some cars, so for painting of the cars, the customer is willing to pay, and that money is included in the cost of the car. But because of your miscommunication in your production process, you are wrongly painted into a different color than what the customer has asked for. And because of that, you have spent some 20,000 rupees extra. Then, and you ask the customer to pay for that. The customer is not willing to pay because that is not adding any value to him. So he is not willing to pay. So any activity which is not adding value to the customer, we call this a non-value-added activity, and that is called as a waste. In lean terminology, we call it a waste. So business non-value activities are again not adding value to the customer, but we cannot avoid it because this will be needed essentially to ensure that we are producing the right product. For example, any quality control, any entries into the ERP system and all. So they are very much needed from the organization point of view to ensure the right product is delivered to the customer. But to the customer, it is not adding value. So whenever we are doing any activity, whenever we are doing end-to-end process, so we need to ensure that we maximize the value-added activities, we minimize the business non-value-added activities, and we keep the non-value-added activities as much as 0. And if you really ask me like how much time you are in a manufacturing setup, so how much of time is spent on the non-value-added activities or the waste, you will be surprised to know that only 25 to 30% of the time is spent on value-added activities. So remaining 70 to 75% of the time is spent on non-value-added activities. That is a waste. So that's why there is a huge opportunity for improving our productivity and quality and the profitability by implementing lean in any organization, right? So that is about the very short this thing about introduction about lean. So lean, you can just say lean means more output to the customer. You can say that the slogan for lean can be more with less. That means more output with less inputs. So we are going to give more and more features and functions to the customer with a lower and lower cost so that your profitability is going to improve. So again, there are 5 basic concepts of lean, 5 pillars of lean we call. So the goal is to deliver maximum value to the customer with a minimum waste. So that is what is lean. And there are 5 pillars. So first thing, if you want to implement lean is you will have to define value from the customer perspective. So whatever the customer is thinking that he is willing to pay, only that is value added. So we need to see whether whatever the activity we are doing, whether that activity the customer is willing to pay for. So we'll have to define the value from the customer perspective. Then in the end-to-end process, whatever we are doing, then we'll have to map each and every activity and then ask this question: is it activity adding value to the customer? If it is yes, then it is a value-added activity. If the answer is no to the question, that means it is not. It is a non-value-added activity. That is a waste. So in the end-to-end process, each and every activity you will have to classify into value-added and non-value-added activities. And then the third point is very important. That is, you will have to create a flow, create a smooth, uninterrupted flow. That means right from the raw material up to the finished goods, the flow of material should be flow of material, or in case of manufacturing, it is flow of material. And in case of service activities, it should be the flow of information. So the flow of material or the flow of information should be very smooth without any interruption. So if the flow is not smooth, and if there are some interruptions are there, for example, there are 5 machines are there in the end-to-end process, 5 processes are there, and we find that there is a frequent breakdown on mission number 3. So if the mission number 3 is going to break down quite frequently, then a lot of inventory is going to be accumulated before the third one. That means flow is not even. So in that case, the output is going to be reduced, and a lot of time and material is going to be wasted. So that's why we need to ensure that the material has to flow smoothly in the end-to-end process. Then the fourth step is to pull the material. So that means whatever the customer is ordering, only we have to produce, and the customer will be just following up with the marketing or the sales team why the material is not delivered to him. Then the marketing will ask the quality control why they are not doing the quality control. Then quality control will ask the production why the production is not offering to QC. Then production will ask stores why the material is not issued. Then the stores will ask purchase why the material order is not placed on the supplier. Then purchase will put pressure on the finance why the payment is not paid to the supplier. And the finance will put pressure on sales again why the payment is not collected from the customer. So then everybody will be pulling the material from the previous stage, and then overall the efficiency will be there. So that's what we call this a pull. So instead of that, if you are going to produce without any of the order from the customer, then we will just produce and keep it in the finished goods, thinking that as and when the order comes, I will deliver right from the finished goods. Then that is not the efficient way of working. So always you have to ensure that you are creating the pull. So the customers are pulling the material from the suppliers so that the efficiency is the best. So the last one is about the perfection. So these first 4 processes, whatever you have seen, if you are going to continuously keep on improving, then overall the improvement will be there. So this 5 pillars of lean, again, the very important thing is about people and culture. The people should be engaged. You should have the maximum engagement from the people. It should be a teamwork, and respect and a culture of continuous improvement are the foundation of lean. So if you are able to implement lean successfully, then you will have happy customers, engaged people, better quality, lower cost, and faster delivery. So in the implementation of lean, again, the value stream mapping is actually the starting point. So we can always say that value stream mapping is the starting point for any lean project. So before trying to understand what is the value stream mapping and how we use it for improving our processes, first we will learn about the different types of waste. So there are 8 different types of waste according to the lean, and these 8 waste can be remembered by remembering the word downtime, where D stands for defects, O stands for overproduction, W stands for waiting, N stands for non-utilized talent or unused talent, non-utilized talent, T stands for transportation, I stands for inventory, M stands for motion, and E stands for extra process. So these are the 8 different types of waste, and I will just quickly go through the 8 types of waste. The first one is defects. So any scrap we are doing in our process or any rework we are going to do, that is going to add cost to us, but again, that is not adding any value to the customer. So we call it as defect. Overproduction means producing items where we do not have any firm commitment from the customer. So sometimes, many times it happens in many organizations that they don't get orders on time. So assuming that the orders will be received at a later point of time, they will produce and keep it in the finished goods, thinking that once the order comes, they will deliver from the finished goods. But if the design of the product has been suddenly changed, or the customer requirement is itself has drastically reduced, then whatever has been produced will go as a waste. That's what we call as a overproduction. So in order to avoid overproduction, we should always produce the right product. That means the product for which we have the firm order from the customer, right product, right quantity. If the customer is asking for 100, you should 100 every week. You should produce and deliver 100 every week. You should not produce 400 at the beginning of the month and deliver to him all the 400 at the beginning of the month. That is going to be a waste. Then the right time. So again, you should deliver at the right time to the customer. You should not send earlier than request, and you should not also send later than is requested. So right time is the right quality. So that's all about the overproduction. So you should always produce only items for which you have the firm order from the customer. Third one is the waiting. So any material waiting for the next stage of operation, that is again a waste. For example, let us see that in the end-to-end process, we have 3 different processes. And you know that all the 3 processes cannot have the same capacity. So maybe the process 1 is producing at the rate of 1000. Process B is producing only at the rate of 500. Process C can produce at the rate of 750. Then when these machines are running continuously, then since machine 2 is consuming less, then it is going to, a lot of inventory is going to be created before the second process, and a lot of material is going to wait for this process to be completed. So again, time is always money, and waiting time is going to cost you. That is a wastage due to the waiting. Non-utilized talent, again, that is a very important concept, and I have asked this question in many of my training sessions. So if I ask my participant, what percentage of your capabilities are being currently utilized by your current organization, they normally come out with saying it's only 50 to 60%. That means only 50 to 60% of their capability are being utilized by the organization. So the balance 40 to 50% is going as a waste. So maybe there may be so many genuine reasons, maybe your skill sets are not required by the organization, or there is a resistance for the workmen and the junior people for this talent to be utilized. So, or maybe the senior management is against it. So many possible reasons may be there. But the fact is 40 to 50% of the employees' talents are not being utilized. So that is again one of the major ways to any organization. Then the fifth one is about transportation. That means unnecessary movement of the material. So if you are going to, because of your poor layout, if the materials are going to move here and there, maybe zigzag manner, so that is going to be a lot of handling rejections may be there, power and fuel, the wastage may be there. So that's what we call the wastage to the transportation. Sixth one is about inventory. Inventory means any material which is stored and without any realization from the customer. So if you are going to have a lot of raw material storage, or the work in progress inventory, or the finished goods inventory, so there may be some genuine reasons maybe there. For example, maybe our materials is coming from some imported source, so it takes around 3 months. So if there is a problem with on the way, some transportation issue is there, or some supplier problem is there, so our production cannot stop. So thinking like that, we may try to build up an inventory for 6 months or 8 months or something like that. But again, this material is going to be blocked, as money is going to be blocked in terms of material, and accordingly, the wastage is going to be the workflow, the money flow is going to be affected. So that is what is the inventory, wastage due to the inventory. So work in progress, finished goods stage. So any work we have, that means we have just invested on the material, and we have invested on the manpower and the machine type. So all the expenses we have incurred, but ultimately we are unable to get the money realized from the customer. So that is going to be a waste. And again, we may not be having the money to pay to the suppliers or the salary to the employee. So a lot of cash flow problems will come if inventory is going to be huge. So that is why it's a waste. And then again, inventory carrying cost. So again, money is not coming without any, it's not coming cheap, right? So it is not coming free of cost. So some interest percentage will be there. So 10% interest percentage will be there. So that is going to be an added cost. Seventh waste is about motion wasted, that is unnecessary movement of the people. So for example, in your work, so if a workman has to bend a bit in order to load the machine, he has to stretch a bit in order to unload the machine, and he has to walk some 50 meters to transfer the material to the storage area. So this bending, stretching, and walking is going to make him tired too soon, and accordingly, his efficiency is going to be reduced, and that is going to be a wastage to the motion, unnecessary movement of people. So again, if the people are asked to work in some extreme conditions, you are not giving a proper working environment. For example, people may be working in an area where there is a lot of heat is there, or a lot of dust is there, or a lot of noise is there. So these problems will make them will affect their health and their efficiency. And again, the that is going to be a waste. So again, in the service related and software development, so the hand pain, neck pain, obesity, back pain, these are all coming because of the motion related issues. So we need to really see where this motion related waste is coming, and we need to take some action. The last one is about extra processing. So more work or higher quality than is required. So if I ask a question to you, maybe you can just type your answer in the chat box. So there are two definitions for quality. So one is the definition of quality. Definition number one is meeting the customer requirements. And the second definition is exceeding the customer expectation. So if these are the two definitions of quality, according to you, which one is the definition for quality? Can you answer in the chat box? So what is the definition of quality? Meeting the customer requirements or exceeding the customer expectation? So what is the definition of quality according to you? Can you just type your answer in the chat box? Okay, meeting the requirements. Yeah, most of you are giving the answer, meeting the customer requirement. So again, if the customer is requiring something, then he will be willing to pay for that. And if he's not willing for that, but we are actually doing something, thinking that the customer is going to be happy, but he is not willing to pay. So then, according to the lean terminology, it is going to be it is not adding value to the customer. It is non-valid activity. That means a waste. So, for example, we are doing some quality control. We are sending some product, and suddenly there was a major escalation at the client's place. Then we take a decision that we will do the double QC. So after doing the final checkup, we will do the second time quality control to ensure that the wrong parts are going to be, the quality is going to be maintained. So this process, whatever you are doing the second time quality, again, that is not actually really needed. So that is the extra processing, and that is again a part of waste. So again, in our workplace, we need to identify where these 8 types of waste is there and take action to eliminate those 8 types of waste. Okay. So now that we have understood what is lean and what is waste and what are the 8 different types of waste, then you can see that these are basic, and we also know what is the 5 pillars. That it is define value, then map the value stream, then create flow, then establish pull, and seek perfection. These are the 5 steps. And then we also learned about the 8 different types of waste. So now we are going to learn what is value stream mapping and how it will help you to solve the problem, right? Okay. So you are seeing 2 pictures here, right? So what is your inference? So what do you understand from this? Can you just type the answer in the chat box? So we are seeing 2 pictures, one on the top and one on the bottom. So what actually is your interpretation of these 2 pictures? So which is good and which is bad? And what is the issue here? Can you just type your answer chat box? So what you are interpreting about these two pictures? Okay, I'm getting some answers. First one is good. Flow of water is good. Okay, need to reduce the rework and reproduct. Yeah. So if you see here, the first one, for example, the customer is, so here again, you assume that it is any manufacturing or service process. So we have some raw material or we have some raw information. And this raw material or raw information has to be processed through some different steps. And then finally, whatever the input we are getting, the output we'll have to give, right? And if there is no choke points or if the flow is very smooth, that means all the processes are running very smoothly without any interruption. Then whatever the customer demand is that, for example, the customer is demanding at the rate of 500 units every day. So right from the raw material up to the finished goods, all the processes are without any interruption. They are producing at the same rate. Then the customer will also receive the 500 parts as his requirement, right? There will not be any interruption. So smooth flow. So you get a higher throughput and the customers are happy. But in your processes, many times what happens is there are some choke points are there, right? So either the inherent capacity of the machine itself is slower, or maybe, for example, assume that this third process. So the machine is breaking down quite frequently, or the machine 2. So it is actually run by a very specialized skilled manpower. So that manpower is on leave quite frequently. So because of all this, again, if we encounter some choke points, that means choke point means suddenly we find that this particular step is becoming low, giving only lower output, right? So then what is going to happen? Even though the first step and second step, so raw material is fine, first step is also fine, second step is also fine. They are producing 500 pieces as required by the customer. But again, the product 3, the choke point is there. So it is giving only an output of 100 pieces. Then the fourth and fifth processes, which are tuned to process 500 pieces in every shift, they will not get the material, right? So they will be waiting for the material. So they will be wasting the time. So if you see here, the wastage, the first one, so because of the choke point, then there'll be a lot of inventory also, which is getting created. So you'll always find whenever there's a choke point, wherever there is some interruption is there, then the previous processes will have a lot of inventory. And we have just learned that inventory is waste. That means a lot of machine time, manpower, and material, everything has been invested, but money has not been realized. So inventory means, again, that is a wastage. And again, in the downstream processes, after the choke point, again, people are waiting for the material. So waiting is also waste. So again, you can see that out of the 5 processes, again, before processes, inventory is the issue, and the later processes, the waiting time is inventory. So choke points always create the bottlenecks. The WAP builds up. You get a lower throughput and delayed delivery. For example, the customer is demanding 500 pieces, but because this choke point is producing only at the rate of 200, then for sending this 500 parts, it will take 2.5 days. So that is going to be, the customer is going to be unhappy. So the impact of the such choke point is a higher WAP inventory in the preceding pages, longer lead time in order to get the same amount as what the customer requests. Again, it's going to take more time. So higher inventory holding cost, delayed delivery, unhappy customer, and lower throughput. So your output is also going to come. So that means your cost of production is going to go up. All these problems are happening only because of this choke point. So the VLC mapping is actually a lean tool that will help you to identify where these choke points are. So that once you are able to identify where these choke points are and what is the extent of the damage because of the choke point, then you will be able to take some action on that. So we can take some action to remove those obstacles or the bottlenecks. And then once we just again free it to having a free flow, then again your throughput, your quality, and all your customer satisfaction, everything is going to improve. Right. So the value stream mapping is called as a starting point for any lean project. Any lean project, if you want to do, first you need to identify what is the problem. So we need to identify which is the choke point, and then so that we'll be able to focus on that, identify what are all the non-validated activities in that particular choke point, and then we remove that. And once this choke point is removed, the entire end-to-end process is going to be smoothened out. Output is going to be smoothened. So this is actually value stream mapping. So you can see that there are some specialized, some shapes are there, some symbols are there. So these symbols are globally standardized, and value stream mapping normally we represent with this globally standardized symbol. So for example, the one which you are seeing on the top middle, so that is the symbol for the customer and customer requirement. And these rectangles are for the sub-processes. And the bottom of the step is the cycle time or the process time. So how much time the material or the information is being processed in that particular sub-process. That is the cycle time. Queue time or waiting time. On an average, how much time does it take from moving from one sub-process to the other sub-process? But you know that whenever you are having multiple processes, it is not that all the processes, all the parts are going to immediately go from first to second, second to third. So always there will be some waiting time, right? So you like to capture the waiting time, average waiting time. And the triangle will always indicate the inventory. So these are all some of the symbols. So whenever we do the value stream mapping, then we do the first what we do is the current state mapping. So whenever the product or service we are producing, then we'll have to map the current status. So first we need to, again, I'm going to explain you the step-by-step process, but I will just, first I will tell you at a very high level. So divide the entire end-to-end process into the sub-processes, right? For example, this example is given for the recruitment process. So the recruitment process, once we receive the request from the concerned department, the HR will initiate the tele-interview. Then after the people who are passing the tele-interview, they will go into the analytical exam. Then from there to the individual oral assessment, then final interview, and then finally job offer. And whoever is passing the job offer, then they will be recruited and they will be handed over to the handed over to the concerned department. So that's the end-to-end process. So first you'll have to divide the entire process into the individual end-to-end process. We'll have to divide into sub-processes. And at each sub-process, we'll have to see what is the current status. What is the current performance. So we need to collect the data on an average, how much time does it take to process that particular sub-process. Then from moving from the first one to the second one, then second one to third one, on an average, what is the waiting time? Sieve ratio is nothing but yield. So if 100 parts are going into the first part, how much is really coming out okay? Because again, some of them may be rejected after this particular sub-process. So sieve ratio is yield. So what is the yield in this particular sub-process? Then what is the number of manpower involved? What is the manpower involved? So FTE here means full-time employees. So how many number of people are involved? And the triangle, within triangle, we have the average inventory. So we need to collect the data, and then we need to, once we have that, then we know that the end-to-end we have all the data. And then we know that here, example, the department, they want 400 people to be hired in 20 days. So that means every 24 minutes, then a person has to be recruited. So if any process we are having, which is taking more than 24 minutes, that is a choke point. So here you can see out of all this, you can see that the final interview is the one which is having the highest process time, that is 78 minutes, and the waiting time is also more. Then we can identify that this is the choke point in the entire end-to-end process. And then again, we need to drill down this final interview into the sub-processes, sub-processes, and then finally, we need to split it into activity. And at the activity level, we need to find out what are the activities which are not adding value to the customer, so that we can take action to either eliminate, simplify, or automate those activities, so that the overall productivity and quality will improve. So once you take this action, so that's what we call as a final, we call as a future state. So for example, currently we are getting, so if this is 78 minutes, then every 78 minutes only we are going to get a person out of the system is to be recruited. But our requirement is 24 minutes, right? So we just identify this process as a bottleneck area. Then we take some action to remove those. Then maybe after taking action, maybe now it has come down to maybe 22 or something like that. So that means now it is within this time. But again, this analytical exam becomes the choking area. So we normally take like every cycle, we call this a cycle. So first cycle, we identify what is the choke point. Then the finally two is the process. Then we again identify the waste, non-valid activities, take action to remove those non-valid activities, and then make an improvement plan, and then implement all the improvement plan, and wait for all the improvement to settle. It will take around 2 to 3 months. Then again you do the value stream mapping. So since you have done a lot of work on final interview, then you can find that substantial waiting time and cycle time reduction is there. But again, don't stop with that. Then you just see what is the next one. Next one is the analytical exam. So again, try to drill down into the activity stage at the analytical exam. And then again, try to identify what are the non-valid activities. And then try to see what activities can be automated, simplified, or eliminated, and then take action. So again, it will take around 3 months. So like that, every 3 months, you do the value stream mapping. So slowly and steadily, the overall improvement will be there. And then you'll be able to increase your throughput. You'll be able to reduce your wastage, improve the quality, improve the throughput. So that is what is the basic concept in value stream mapping. So you map the current status, split the process into the sub-processes, then collect the data, identify which is the choke point, then focus only on the choke point, and then take action to improve those, reduce those non-valid activities, and then make an improvement plan, and then you implement. Again, every 3 months, you repeat the cycle. So within 5 to 6 cycles, you will be able to find a lot of improvement. So this is what is the basic concept of the value stream mapping. Second, this is what is the step-by-step process for doing the value stream mapping. So draw the internal Excel customer at the top of the page and list the requirement. So this particular symbol is for the customer and the customer requirement. So here again, as I told you, the requirement is to hire 400 people in 20 days. And we are doing this value stream mapping for the recruitment process. So for the recruitment process, what is the entry point or the entry and exit point for the value stream? So the entry point for the recruitment process is the receipt of job request form. So once a particular department manager requires some manpower, then he has to fill a job request form. That is the entry point. And once the required manpower is onboarded, they will be handed over to the department. That is the exit point. So mark the entry and exit point. Then draw all the processes between the entry and exit, bringing it to your furthest downstream point. So start from the final output, that is the HR onboarding. So before that, what is the process? That is the job offer, final interview, oral assessment, analytical exam, tele interview, right? So map, just list all the sub-processes. Then just start collecting the data about what is the cycle time, queue time, yield, number of employees, number of people working, inventory, etc. So you just try to collect the data, and then you just identify which is a choke point, and then try to go deeper into the choke point, and then try to take some action. So here you can see. So this is what is so that I have seen as a water flow. Here I'm just seeing actually production process, right? So we have the raw material, but here you can see the material flow is very smooth. So no choke points are there. So you're getting a continuous output. But here you can see here the choke point is there. So the cycle time is slow. So the WAP is getting built up in this area before. And then after this thing, again, the production is going to be held up, right? So it's going to be happens that. So normally we calculate like based upon the customer requirement and the available time with us, then we will have a target. So here the customer needs he needs 500 parts every day, and we have 480 minutes. That is 8 hours we are running shift. 480 minutes we have with the available time. and we need 500 pieces. So the tuck time, that means what is the time frequency in which we should get a product. So that is 480 divided by 500, that is 57.6 seconds. So that is what we call as a tuck time. And then we need to capture whenever you are doing the current state mapping, then we just calculate on an average how much time each part is spending time here. So here it may be like 50 seconds, 40 seconds at all. So everything is less than 57.6. So that means material flow is smooth. But here you can see that the third one, the time taken is around 95 minutes, whereas it has to be completed within 58 minutes second. So that means this becomes a choke point. So then we identify, split into the activities level, and then we try to reduce those non-valid activities. And after taking action, then we will be able to establish a clear flow. So this is how we do the value stream mapping, right? So these are normally what are the possible improvements we can do whenever you find that there are choke points are there. Then what are the possible improvements we can do? So either we can go for parallel capacity. For example, in the choke point, the capacity of the machine itself is only half when compared to the other. Then we can just put one more machine in parallel so that we'll be able to avoid the choke point. That means adding more machinery. Other thing is work for standardization. Maybe there is some variation in the output. So we need to identify why this problem is happening, and then we can try to take action. Or change over time. Maybe here we are to frequently change over to whenever we move to another component, we are taking more time. That means we can try to see how we can reduce the changeover time. Or we can see how we can improve the quality, reduce the scrap, right? So depending upon the nature of the problem, whatever we are having, then we'll be able to identify those reasons whenever we are doing this current state mapping. So because we are measuring everything, right? We are measuring the process time, we are measuring the quality or percentage yield, all those things we are measuring. So we'll be able to know exactly what is the problem at the choke point, so that you can take action to remove those problems, and then we'll be able to get the improvement, right? Okay. So this is what is normally using the symbols, globally recognized symbols. So this is what we take, right? Okay. So this value stream mapping will help you to drastically reduce your overall lead time. So right from the raw material up to the finished goods. So for example, sometimes you may take around 3 days. So from 3 days, if you want to reduce it to 2.5 days or 2 days, then you can do that. You can reduce overall your manpower requirement. You'll be able to reduce your inventory cost, everything. So all those improvements you'll be able to do by doing the value stream mapping, right? Okay. So now what we will do? So we have prepared a standard set of templates. So using the template, we will now try to solve a problem from one of the participants, right? So the template what you are having is like this. So first you need to select the project, right? So what is the problem you are trying to solve? So which industry you are working? So what product or service you are making? Which function you are in? Quality, maintenance, or production, or whatever it is. Then we can just, once you give these inputs, then we'll be able to get the end-to-end. So all from this onwards, again, we can generate from the AI tool, right? And then we'll just see how a problem can be solved, right? Okay. So I will now move on to ChatGPT. Okay. Any one of you who would like to volunteer, can you say yes? Then you'll have to give these inputs. So who would like to come forward? Yes, Uttam Singh. So which industry you are working? Manufacturing or service? Uttam?
Manufacturing. Manufacturing.
Okay, so you're into manufacturing. So what is the product you are making?
We are making glass, architectural glasses. Yeah, basically we are processing architectural glasses.
So manufacturing, architectural glass. Which function you are in?
I am in production.
Okay, production. Okay. So now I'm going to tell you, like ask, like I'm just going to ask for the end-to-end process. It will give just to validate whether the end-to-end process is right, and then from there you have to pick up, right? Can you list the end-to-end processes in the manufacturing of architectural glass, right? End-to-end processes in the manufacturing of architectural glass.
Rather than putting the manufacturing, we should tell processing of glass, because manufacturing will be this different process altogether.
So what you are looking for is not this.
No, actually, this is the process shown for the float glass manufacturing.
Okay.
So my industry is processing, means we receive raw material from the float. Here the response which are given by ChatGPT is related to the float manufacturing.
Okay.
So instead of manufacturing, you should write processing.
Right. Is it right?
Yes. Now it's right.
Okay. Okay. Now we have the end-to-end process of this, and then from that we can select at least 10 problems, right? So I'll just ask you to randomly generate 10 problems that can be solved using VSM. And you can just go through the list and then you can recommend one. Or if you feel that already you have some problem, and you can just tell about that. So I'll just ask it to give only the list. So list 10 problems that can be solved using VSM. So long order to dispatch lead time, excessive inventory, bottleneck at the tempering furnace, frequent waiting time before processing, low throughput, excessive material movement, multiple inspection points, high rework and reprocessing. So would you like to select any one of these, or you have any specific problem in mind?
I have problem like there is a lot of wastage when we are cutting the glass. There is a lot of wastage. Means optimization yield is 75%.
So you are saying that in this process, glass cutting?
Yes, in the glass cutting.
So the problem you want to solve is the glass cutting, right?
Yes.
So normally I'll just say that how you are measuring the is it a percentage, glass yield percentage? So which one you are measuring for? Glass yield
material utilization.
Okay, material utilization, right?
Yes.
So that is the problem you want to solve. So we will write this thing is a wastage in glass cutting. Ten metrics. Metrics is percentage material utilization. That's what you want to improve. So what is the current problem? What is the current performance?
Current problem is
what is the current utilization?
Means the optimization process is missing.
No, I'm saying what is the percentage of utilization now? Currently.
75%.
So current percentage utilization is low at 75%, right? So what is the
Yes.
target you want to keep? What is the
90%.
benchmark? Is achievable? 90% is achievable?
Yes, yes.
Increase percentage material. 90%, right?
Yes.
Okay. So the process taken for implement of VSM is glass cutting.
Yes.
So what is the customer demand? So on an average, how many pieces are required? Whatever the output you are giving, your line. So on an average, how many pieces you are making every day
Mm,
in terms of
Actually,
weight,
we,
numbers or weight or something like that?
we measure the output in square meter, the glass
Okay.
area. So it's
Okay.
around 500 square meter per day.
That is what is the customer demand, right?
Yes.
Okay. So what is the available time? Means working time, you are working one shift, two shift, three shift,
480 minutes. One
480,
shift.
480 minutes. So 480 minutes is the, so every minute, almost every minute you should get a 1 square meter of this thing glass out, right? Produce
Correct.
glass out. So the takt time is the available time divided by the customer demand. So that is equal to 480 divided by 500, roughly around 58 seconds. Okay. So now I will just give the, I will ask now ChatGPT to, so just give the thing, say that. So my student wants to do VSM to improve personal material utilization from 75% to 90% in the glass cutting process. So can you give customer demand is 500 square meters per day and available time is 8 hours. Can you give, I'm just asking you to give dummy data to capture the current state. So that means whenever your process is like piece by piece, it is going to come out. So it is going to give some dummy data. So customer demand is so much, available time. So takt time is 57.6 seconds per square meter. Okay. So now this is what is the data it is giving. So right from the order review, glass is cutting optimization, etc. So what is the cycle time? What is the changeover time? What is the uptime that in terms of material machine utilization? So how many people are involved? What is an average inventory? So what is the input per square meter and what is the output per square meter, right? So it is giving the data. So based on that, the current state summary. So again, you will have to on a daily basis, maybe 15 days or 1 month, you collect the data, right? At each and every stage, like I have shown in the diagram. So you just capture what is the cycle time, what is the changeover time, all these things, yield, everything is you are capturing here. So the current demand is 500, available time 480, takt time is 0.96 minute. Total input is so much. Good output is only 465. Required output is 500. So overall material utilization is 465 divided by 670, that is 75%. So total wastage is 25%. So output gap is so much. So bottleneck process is the CNC cutting. So highest WAP is coming before that. So the total WAP before this is 1,400. I think the WAP 1,400. So total value at a time is only 3.4 minute per square minute. So estimated lead time is 2.8 days, right? So this is what is the current status, only 70% against the target of 60, right? So this is what is the current status. So now if you want to, this is the current state mapping, flow analysis. So again, we have calculated that lead time, process time, bottleneck process, etc. We have identified. So then you'll have to identify the root causes for the top 3 root causes. So you have identified the bottleneck process. So lesser output in the CNC cutting process. So once you have identified the bottleneck area, then can you identify? So again, you can use the tools like fishbone diagram, YY analysis or something like that. So can you identify? I'm just asking for the 3 root causes, 3 top root causes for the bottleneck process in CNC cutting. So do you think the CNC cutting process is the problem area? Do you agree with that, or maybe?
Yes.
Yeah. So the top 3 root causes are the poor cutting optimization of the nesting plan. So more offcuts, more cutting paths, higher scrap and longer cutting time per square meter, frequent size or specification changeover. So process time is also more, changeover time is also more waits for program changes, class loading changes, etc. A machine downtime or lower uptime, right? So these are the. So it is again, you have to really see based upon your own data, you have to find out which is the bottleneck, what are the root causes for that. So once you have identified the root causes, then you'll have to go for the future state VSM. So in order to achieve the future state, prepare an action plan. So in order to achieve the target, what actions we need to take? So these are the things, like these are the root causes. And so this is what problem we want to improve from 75 to 90% within 4 months while meeting the customer demand of 500 square meter per day. So these are the root causes which I have identified. So for these root causes, these are the improvement action. Who is going to do? Which tool you are going to use? Who is responsible for that? What is the time need to be taken? Right. So once you have implemented this action, again you do the this thing, current and future state comparison. Before after, right? Before improvement, what are the thing, and after improvement, what is that? So now here you can see. Now the input glass required previously was 670, so that has now come down to 556. So CNC uptime, previously it was 82, that has come to 85%. So change over time. So because of taking all these actions, so we have increased the uptime, we have reduced the change over time, WAP is reduced, throughput is increased. So lead time is reduced. So OE, right? These are the improvement. So once because of this improvement, so these were the expected benefits. So raw material consumption is reducing, disposal cost is minimized. So these are the financial and operational costs. Right? So these are 90 days implementation roadmap. So in order to implement those actions. So once you have implemented and then you have before after comparison, what is the business impact? Then you need to really see what are the actions you are going to take. Some sustaining mechanism, right? So now that you have made the improvement, in order to sustain, then these are the actions you are going to take, right? So these are stabilization. So once you have improved this, you have to stabilize this process. Then we'll have to do improve the outflow. These are the activities you have to take. And then in order to sustain layer process audits, visual management boards, control plan implementation, feature state validation. So these are the actions we are going to take, right? So again, I think coming back and ending. So we were able to identify that the CNC cutting process is actually creating the choke here. So by taking the action to improve reduce the changeover time and reduce the scrap or something like that, then we were able to finally reduce the overall scrap. So the collecting the data is actually a bit, you'll have to do it patiently, and the more and more accurate data you are going to collect, then accordingly your output or the results will be right. Okay. So this also will send along with so we will share the recordings of this session along with the PowerPoint presentation and this example, whatever we did for your reference, so that you can always have it. Okay. So with that, I'm ending the session now. So if there are any questions anytime, you can just ask me now. So why use the ChatGPT? So you can use any of the, because again, say for example, if I am going to give any example from my own this thing, then again, it will be very difficult for you to understand. So once I share this template, you can also try for your own process, right? You can use ChatGPT, you can use Claude, you can use Gemini, anything which you are convenient. So it will create the dummy data, and with the help of the dummy data. So again, I think technically it was okay, right? Utpal Singh? Technically, all those information was right?
Yes.
Yeah.
Absolutely.
So then, at least since you are you are seeing some terms which you are encountering on a day-to-day basis, then you'll be able to appreciate, and then you will be able to your understanding will be better. Right?
Yeah. Okay.
Yeah. Certificate also we will give. So hopefully by next. So today is Tuesday. Right? So Friday, this coming Friday or Saturday, within that you will be able to get that certificate. Okay. Okay. Any questions? Any doubts? You can ask me now. Others who want to quit, you can quit. But if you have some specific questions, then I'm here to answer it for some time. So any feedback you can also give. Like maybe I think this is
Hello,
normally.
sir.
Yeah. Yes.
So, good evening, sir.
Yeah.
So, sir, you have any organization to provide the training on this VSA and the
Yeah.
other process improvement?
Yeah. We
So, could
normally.
you
We normally
share me
conduct
some little bit information?
Yeah, we conduct this Lean Six Sigma, Green Belt and Black Belt session continuously every month. So that is going to be a 1 month course, means every Saturday and Sunday, 7:30 p.m. to 11:30 p.m. So there you this actually VSM is going to be a part. Maybe it's going to be only 30 minutes I will cover, but like that you are going to be exposed to a lot of tools. So right from the fishbone diagram, Y-by analysis, and all those things, control charts and everything. So using those tools, how you are going to solve your process problem. So again, you will be solving a problem from your own area of work. We will make you. So we have a template which is having 43 questions. So as you are answering these 43 questions one by one, then right from identifying the problem, then defining the problem, then collecting the data, analyzing the root causes, and then taking action. So everything you will be just creating this dummy data with the help of the ChatGPT. So at the end, once you complete, then you will be able to have a clear idea how you can solve your problem using the Six Sigma methodology and how you can document that, right? So in addition to that, we also conduct maybe every month we conduct some 3-4 webinars like this. So we conduct this type of webinars on value stream mapping, yellow belt sessions we conduct, then AD report, so failure FMEA, control chart like that. So anything related to quality. So our strength is more on customized training on any of the quality management. So Lean Six Sigma is a very regular program. Every month we have, and then every month we have these webinars on these short topics, 60 minutes to 90 minutes.
Could you tell me about your organization name and details?
Yeah, our company name, I'll just write it down, is ICEQBS, ICEQBS. So we are based at Chennai. So we are actually, the company is in existence for the last 12 years. And I'm actually the main trainer here. So I'm actually having a total of 30 years industry experience, both in manufacturing and service companies, both in production and quality. I was in electronic component manufacturing and IT service. And then I started this company in 2015, 12 years, 11 years back. So we are specialized in the customized content development, then training and implementation support for lean management, Lean Six Sigma, and project management. So we are the authorized training partner for the Council for Six Sigma certification. They are the number one Six Sigma accreditation body in the globe. And we are also the authorized training partner for the PMP exam. I think you would have heard about it, Project Management Professional. So we
Yes.
are authorized to provide this 35 hours of training certificate so that you can take which is a mandatory requirement for taking the PMP exam. So our expertise, our regular programs are on Lean Six Sigma, Green Belt, Black Belt, and PMP. Every month we'll have one session. And then we have these webinars. And then we have also some self-learning material is there, like recorded sessions will be there on specific topics like control charts, FMEA, failure mode effect analysis, then AT problem solving, and the value stream, A3 problem solving. So by using these simple tools, then how to solve the process problems and how to make the improvement. So our major customers, so I have worked with Amazon for 5 years for creating a infrastructure for Lean Six Sigma, right from the selecting the project, then reviewing the project at each stage, and guiding the project to completion and successfully approving the project completion. So I was working with them for 5 years. So I have also worked with renowned companies like Asian Paints, Tata Chemicals, then L&T Valves, um, Tata Chemicals, Tata Communications, Standard Chartered Bank, Pfizer Healthcare, ESAP, Lennox, ACLR. So Accenture also recently have taken the training. So these are all some of the companies where I have worked either as a consultant or as a trainer. So our website, I'll give you, I will put it in the chat. So www.ICEQBS.org. So there all our details will be there about our company, everything will be there. All information will be there.
What will be cost for the green belt and black belt? Could you tell?
Yeah, so again, depending upon the course you are taking, so roughly it will be for green belt, it will be around 12,000 for the entire course. And for black belt, it will be 15,000, 15,000. So,
Okay.
and then you can also take the combo, that is green belt and black belt combo. So some other courses are also available. So our sales people may be in touch with you. So as I told you, the next July batch is actually starting on 10th of July. I think it's a Saturday. 11th of Saturday,
Okay.
11th July. So if you're interested, then you can join that. So again, that using a lot of other advanced tools, how you can solve your process problems. Again, you will be, again, as I told you, we'll be learning all the concepts with the help of a case study. One case study that is about a pizza making company where they have around 20% scrap rate. So how they were able to come out of this problem by using the Six Sigma methodology. So again, I have the dummy data already created. So with the help of the Minitab, which is actually a statistical software. So again, you will be having the access to the statistical software also, so that you can use that software for your day-to-day analysis of the data. So that we will demonstrate in the class. In addition to that, you will be asked to do a project in your own area of department, right? So you can select your own problem, which is very relevant to you, and then how that problem can be solved using this methodology. So a set of 43 prompts are there. So using that, then you will be able to get a clear understanding. So do you give training for IATF? Okay. So the IATF now this core tools. I think since you are familiar with this word IATF, so we actually give training for these core tools, right? core tools. So, but again, we are not given this public session till now. So we will be going for that shortly. But we have the content for that. 5 these core tools, no? PPQ, APQP, and PPK, all those things. Control charts and everything, measurement system analysis. So all those tools, we have got this thing, and then so we will just. I think you can be in touch with our sales people. So whenever you want to attend any of your courses or whenever there is any sessions, then you can. Yeah, as I told you, I will share you this Word document, the prompts, and I will also share you the this output for the chat GPT. So that both of these along with the you will get the recording for this session. You will get the PowerPoint presentation what I use for taking this training. You will get the prompts and also you will get the chat GPT output for your reference. Okay. Any other questions? Any doubts? So do you suggest recommend any or suggest any topics where you want to maybe we can say? Yeah, if you are already certified with yellow belt, then you can move to green belt. Green belt. Yeah. Yes, definitely you can. Okay. So our next webinar, maybe you can have. Maybe we will have it. Maybe every week or every alternate week we gather this thing. So you will definitely get the information. And if you are would like to join, you can always join. Okay. Okay. Any questions? Then we can just wind up. Thank you. Thank you for your patience. And then hope to see you later. Thank you. Bye. Bye.